This week, NASA struck gold with a holy finding, the holy grail of planetary research: flowing liquid water, which could one day perhaps sustain life. NASA has announced new evidence of water flowing on the surface of Mars. The dark streaks in the images provided are believed to be liquid, extremely salty water. The NASA rover, dubbed Curiosity, keeps making astonishing new discoveries on Mars. At one time, the rolling lab might have moved directly into an ancient riverbed. How significant is this discovery? First and foremost, it's another piece in the puzzle of what Mars used to be like. It confirms earlier speculations that there must have been rivers and liquid water. The age-old question, is there life beyond Earth? May have advanced significantly with NASA's announcement of this extraordinary discovery. While evidence of water in the form of ice or fleeting surface flows has been observed in the past, this marks the first time scientists have confirmed the presence of vast, stable liquid water reservoirs on the red planet. This breakthrough could reshape our understanding of Mars and its potential habitability, opening new doors to exploration and fueling our endeavor to discover life on other planets. NASA's latest findings result from decades of meticulous research and technological advancements. The search for water on Mars has been one of the primary objectives of Mars exploration. Early missions, like those of the Mariner and Viking programs, suggested that the planet once had a wetter and more hospitable climate. Spacecraft like Mars Odyssey and the Mars Express detected evidence of hydrated minerals and subsurface ice. Rovers Curiosity and Perseverance have since uncovered traces of ancient deltas and riverbeds, reinforcing the theory that Mars once contained large bodies of water. However, it wasn't until the deployment of the Mars Reconnaissance Orbiter, MRO, and its radar instrument, SHARAD, shallow radar, that scientists began to consider the possibility of subsurface liquid water. These suspicions gained traction in 2018 when radar data suggested the presence of a liquid lake beneath the southern polar ice cap. Nonetheless, there was no conclusive evidence, leading to debates in the scientific community. Fast forward to 2025, NASA's revolutionary discovery is credited to a new generation of instruments aboard the Mars Ice Mapper, MIM, launched in 2028 as part of a collaborative effort involving NASA, ESA, and several other space agencies. Equipped with high-resolution radar systems capable of penetrating deeper into the Martian crust, MIM has provided clear proof of massive subsurface oceans spanning hundreds of kilometers beneath Mars' northern lowlands and southern polar regions. NASA's analysis of the data reveals that these underground oceans are not mere pockets of water, but entire reservoirs comparable in volume to Earth's Arctic Ocean. Situated several kilometers below the surface, they are insulated by layers of rock and ice, preventing them from freezing despite Mars' frigid surface temperatures, which can drop as low as -125 degrees Celsius (-193 degrees Fahrenheit) at the poles. How is the water staying liquid in such extreme conditions? Scientists attribute this to a combination of factors, including salinity, geothermal heat, and pressure, akin to deep-sea environments on Earth. Mars water likely comes from brine pools rich in salts, particularly perchlorates, which significantly lower the freezing point of water, enabling it to remain in a liquid state. Additionally, Mars' interior still retains heat from its formation and radioactive decay, supplying sufficient warmth to maintain liquid water beneath the surface. The weight of the overlying rock and ice exerts enough pressure to keep the water in a liquid state. This unique environment presents an enticing analogy to the subsurface oceans on Europa and Enceladus, icy moons considered prime candidates for hosting extraterrestrial life. The discovery of liquid water oceans on Mars has profound implications for astrobiology. Liquid water is a fundamental prerequisite for life as we know it. Even in Earth's most extreme environments, such as hydrothermal vents, subglacial lakes, and highly saline brine pools, life finds a way to flourish. Could the same be true for Mars? These underground oceans could provide a stable, protected environment for microorganisms capable of withstanding high salinity. Potential energy sources, such as geothermal heat or chemical gradients, resemble conditions where extremophiles thrive on Earth. If life ever arose on Mars, these oceans might serve as its last refuge. Even if life no longer exists, the oceans could contain biosignatures, chemical or physical evidence of past life, providing irrefutable proof that Mars was once a living world. This discovery underscores the universality of water as a cornerstone of habitability. It reinforces the idea that other celestial bodies with subsurface oceans, like Europa, Enceladus, and Titan, may also harbor life. NASA's announcement is a game-changer for the next phase of Mars exploration. The logical next step is to directly access the underground oceans. This will require sophisticated drilling technology capable of penetrating miles of ice and rock. NASA and its partners are already developing such systems, including concepts like the Cryobot and the Mars Ice Mole, specialized instruments designed to detect and analyze organic compounds, isotopic ratios, and microbial life. These tools will play a central role in upcoming missions, helping researchers determine whether Mars' oceans are merely reservoirs of water or potential cradles of life. The presence of liquid water on Mars also strengthens the case for human colonization. Access to water is critical for life support systems, oxygen production, agriculture, and rocket fuel. These subsurface oceans could serve as a sustainable resource for future Martian settlements. However, the discovery raises important ethical and scientific concerns. Any mission aimed at exploring subsurface oceans must adhere to strict planetary protection protocols to prevent contamination with Earth-based microbes. While the discovery is groundbreaking, accessing these oceans presents significant challenges. Innovative engineering solutions will be necessary, as deploying such technology on Mars' harsh terrain is no small feat. Ensuring that Earth organisms do not contaminate Martian environments is a top priority, requiring sterilization techniques that balance planetary protection with scientific objectives. Distinguishing between abiotic and biotic processes in Mars' oceans will also be complex. Certain chemical signatures may result from geological processes rather than biological activity. As space exploration becomes increasingly global, coordinating efforts among nations and private entities will be essential to maximize scientific benefits and avoid duplication of efforts. The discovery of oceans on Mars is not just a scientific milestone, it is a moment of profound philosophical and cultural significance. It challenges us to rethink our place in the universe and Earth's singularity as a cradle of life. For centuries, humans have contemplated the night sky, wondering if we are alone. This discovery brings us one step closer to answering that question. Moreover, it reinforces the importance of understanding and preserving our own planet. As we uncover the secrets of Mars, we are reminded of Earth's fragility and the need to protect its ecosystems. Mars may offer insights into planetary evolution and climate change, shedding light on how to address similar challenges on Earth. NASA has already announced plans to accelerate its Mars exploration program in response to this discovery. One of the key milestones will be the Mars Subsurface Explorer mission, scheduled for 2028. This mission will deploy an advanced robotic drilling system capable of reaching the underground oceans and conducting in-depth analysis of their composition and potential habitability. Human missions to Mars, planned for the 2030s, will also be influenced by this breakthrough. NASA's Artemis program, which aims to return humans to the Moon, is seen as a stepping stone to Mars. The discovery of liquid water oceans strengthens the case for human exploration, as astronauts could play a critical role in conducting in-depth research. Collaboration with private space companies like SpaceX and Blue Origin will be crucial in developing the technology needed to explore and utilize Mars resources. NASA's discovery of liquid water oceans on Mars marks a significant moment in the history of space exploration. It is a testament to human curiosity, perseverance, and our relentless pursuit of knowledge beyond Earth. Curiosity, ingenuity, and determination define us as we stand on the brink of answering one of the most important questions facing humanity. Are we alone in the universe? Discovery fuels our imagination and drives us to push the boundaries of what is possible. Once considered a barren wasteland, Mars has revealed itself as a world that is both dynamic and complex, with the potential to harbor life. The journey to uncover its secrets is just beginning. The next few decades promise to be an exciting era of discovery, collaboration, and innovation as humanity takes its first steps into the depths of the Martian subsurface. Somewhere, in the words of Carl Sagan, something amazing is just waiting to be discovered. Recognizing that something might lie beneath Mars' icy crust, waiting for us to find it, is a profound realization. The discovery of liquid water on Mars is not just a milestone in the search for life beyond Earth, but also opens up significant avenues for future exploration. In the coming years, the quest to understand the Martian subsurface will likely expand with advanced robotic missions and, perhaps, even human expeditions. These missions will focus on locating deeper layers of Mars, seeking to understand how these subsurface oceans formed, how they have been preserved, and what potential they hold for sustaining life or providing resources for future colonization. One of the immediate challenges scientists face is determining the full scope and distribution of liquid water beneath the Martian surface. Despite this remarkable achievement, much of the subsurface remains unexplored, and the precise locations of these underground oceans are still the subject of ongoing research. Multiple layers of ice and rock covering these oceans make direct observation difficult. Future missions will require highly specialized equipment capable of penetrating these layers, revealing deeper insights into Mars' geological past. Using new radar technologies and advanced drilling techniques, scientists aim to collect data on the chemical composition, salinity, and other factors that determine the water's ability to sustain life, particularly microbial life. As technology advances, Mars exploration is expected to include more sophisticated techniques, such as autonomous rovers and landers equipped with state-of-the-art analytical sensors. For example, the development of high-tech drills capable of reaching the deepest recesses of these subsurface oceans will be crucial. In addition to examining liquid water, missions will likely focus on identifying potential sites for long-term human settlement, where underground water could serve as a vital resource for drinking, farming, and generating oxygen. In this regard, the discovery of liquid water significantly reshapes our understanding of Mars' habitability. Previous models portrayed Mars as a hostile environment due to its cold, arid surface conditions. However, the presence of liquid water beneath the surface suggests that Mars may be more Earth-like than previously thought. This discovery opens up possibilities for terraforming, modifying Mars' environment to make it more suitable for human settlers. Debates have already begun regarding how humanity might utilize the Martian subsurface water to support sustainable colonies. Extracting water from underground sources could provide a reliable resource for astronauts and settlers, reducing dependence on Earth-based supplies. Beyond the possibility of human colonization, the discovery of water on Mars underscores the need to preserve the planet as a pristine environment for scientific investigation. The implications for planetary protection are significant, as the introduction of terrestrial organisms or contaminants could interfere with research and potentially compromise the integrity of any native Martian ecosystems. Strict planetary protection protocols must be enforced to prevent contamination, ensuring that any potential biosignatures or life forms remain unaltered by human activity. This presents an ethical dilemma. Exploration must balance scientific curiosity with the responsibility to avoid modifying Mars' natural environment. Another fascinating aspect of this discovery is the opportunity to learn more about Mars' history. The presence of liquid water beneath the surface suggests that Mars may have once had a much warmer and wetter climate, possibly with stable bodies of water on its surface. This raises critical questions. Why did Mars transition from a potentially habitable world to the cold, arid planet we see today? By studying the conditions that allowed water to persist beneath the surface, scientists hope to gain insights into planetary climate change and evolution. Such research could also help us understand the mechanisms behind climate shifts on Earth, offering potential solutions to the challenges we face with climate change. Additionally, the discovery of water on Mars could have profound implications for our understanding of the broader solar system. If Mars harbors subsurface oceans, it increases the likelihood that other celestial bodies, such as Europa, Enceladus, and Titan, may also have similar environments. These moons of Jupiter and Saturn are already considered prime candidates for hosting life due to their subsurface oceans. The presence of liquid water on Mars strengthens the possibility that life exists elsewhere in our solar system, expanding the scope of astrobiological research. As scientists continue their search for habitable environments, this discovery serves as a powerful reminder that life may not be confined to Earth alone. Furthermore, the potential for microbial life in Mars' subsurface oceans could yield critical insights into the origins of life itself. If life ever arose on Mars, studying it could provide a window into the fundamental processes that lead to the emergence of life across the universe. The confirmation of past or present life on Mars would have profound implications for our understanding of biology, evolution, and the conditions necessary for sustaining life on other planets. The realization that liquid water exists beneath Mars offers exciting opportunities for further scientific and technological advancements. While the journey ahead presents significant technical and ethical challenges, the potential rewards are immense. As humanity pushes forward, we move closer to understanding the history and future of Mars. This discovery serves as a catalyst for exploration, collaboration, and a broader understanding of the universe. Ultimately, it may help us answer one of the most profound questions of all. It is likely that the surface exploration of Mars will expand, utilizing cutting-edge robotic missions and perhaps even human expeditions. These missions will focus on uncovering the deeper layers of Mars, seeking to learn how the subsurface oceans formed, how they have been preserved, and what they could be used for, whether preserving life or providing resources for colonization in the future. One of the immediate challenges for scientists will be to determine the full extent and subsurface distribution of liquid water on the Martian surface. Despite the breakthrough, the majority of the subsurface remains unexplored, and the precise location of these oceans is still a subject of ongoing investigation. The presence of multiple layers of ice and rock over these oceans also makes exploration difficult. Future missions will need to use highly specialized equipment capable of breaking through these layers, providing insights into the deeper geologic history of Mars. With new radar and drilling technologies, scientists aim to collect data on the chemical composition, salinity, and other elements that influence the water's ability to support microbial life. As technology advances, research into Mars is expected to incorporate additional sophisticated techniques, such as autonomous rovers and landers equipped with advanced sensors that can analyze the chemical composition of the water on Mars directly. For example, the development of high-tech drills capable of reaching into these oceans' darkest recesses will play a crucial role in these efforts. In addition to analyzing the liquid water, missions will likely focus on determining potential locations for long-term human settlement, where underground water could provide essential resources for drinking, farming, and generating oxygen. In this regard, the discovery of water significantly changes the narrative surrounding the feasibility of human life on Mars. Previous representations of Mars as a hostile environment were largely based on its cold, arid surface conditions. However, the presence of liquid water beneath the surface suggests that Mars may be more Earth-like than initially thought. This discovery opens up possibilities for terraforming, modifying Mars' environment to make it more suitable for human settlers. Debates have already begun regarding how Martian subsurface water could be utilized by humanity. Surface water could sustain colonies by enabling the production of essential resources like food, water, and fuel. Additionally, extracting water from underground sources could provide a viable option for astronauts and settlers, reducing their dependency on Earth-based supplies. Beyond the potential for human colonization, the discovery of water on Mars also highlights the importance of preserving Mars as a pristine environment for scientific investigation. The repercussions for planetary protection are significant, as the introduction of terrestrial organisms or contaminants could interfere with scientific research and possibly compromise the integrity of potential Martian ecosystems. Strict protocols for protecting the planet will need to be established to safeguard against contamination, ensuring that any potential Martian life forms or biosignatures are not destroyed. This presents a moral dilemma for scientists, as exploration needs to balance curiosity with responsibility to avoid altering the Martian environment. Another fascinating aspect of this discovery is the opportunity to learn more about the history of Mars itself. The presence of liquid water beneath the surface could offer vital clues about the planet's past, suggesting that Mars may have once had a much warmer and wetter climate, with stable bodies of water on its surface. This raises questions about why Mars transitioned from a more habitable environment to the cold, arid world we see today. By studying the conditions that allowed water to persist beneath the surface, scientists hope to gain insights into the planet's climatic evolution and significant changes over time. This information could also help scientists comprehend the driving mechanisms behind climate shifts on Earth, potentially offering solutions to some of the problems we face as a result of climate change. Additionally, the discovery of water on Mars could have significant repercussions for our understanding of the wider solar system. If Mars harbors subsurface oceans, it increases the likelihood that other celestial bodies, such as Titan, Europa, and Enceladus, also have environments that could support life. Jupiter and Saturn's moons are already considered highly qualified candidates for containing life due to their subsurface oceans. The presence of liquid water on Mars further supports the possibility that life could exist elsewhere in our solar system, intensifying the search for extraterrestrial life beyond Earth. As scientists continue searching for habitable environments, this discovery serves as a reminder that life may not be confined to our planet alone. In addition to the possibility of life on Mars, this finding could open new avenues in the field of astrobiology. The search for microbial life in Martian oceans could provide significant insights into the origins of life itself, if it ever existed. Studying Mars' subsurface water might offer a window into understanding the processes that led to the emergence of life in the universe. The discovery of past or present life on Mars would have profound implications for our understanding of evolutionary biology and the conditions that make a planet suitable for sustaining life over the long term. The discovery of water beneath Mars presents exciting possibilities for further scientific and technological advancements. While the road ahead is difficult due to numerous technical and ethical considerations, the potential benefits are immense. As humanity moves closer to understanding the history and future of Mars, this finding serves as a driving force behind research, collaboration, and a deeper comprehension of the universe. Ultimately, it may help us answer one of the most important questions of all: are we alone in the universe?